Hi everyone, welcome to my channel Student the Brand, that is STV. So in this channel we'll be getting the content of IIT-JEE, NEET, CBSE class 11 and 12. Today topic is motion in a plane, that is physics, CBSE class 11, chapter 3. Now topic resolution of a vector and two-dimensional 2 and 3-dimensional representation of a vector. This is a today topic. You can see the direction of vector, how we have to mention. Direction is the spatial orientation of a vector. Suppose I am taking this x-axis and y-axis, so I am taking this x-axis and y-axis. If I want to represent the direction of the vector, so if I place like this, okay, so we have to take from positive x-axis in anti-clockwise direction. This is a positive x-axis, this is negative x-axis, negative y-axis and positive y-axis. So we can take from here, we have to represent the vector from positive x-axis in anti-clockwise direction. Suppose this is a bar you can take. If the angle made by the vector a bar is 120, then an angle is taken. So you can see a bar makes 120 degrees with positive x-axis. Or suppose if the direction of vector is denoted in terms of geographical directions, like same x-axis, y-axis I'm considering here. If you take this is x-axis, positive x-axis, negative x-axis, positive y-axis and negative y-axis. Here you understand very clearly. So I'm taking here this a bar vector, I'm considering this a bar vector. If you represent this is 30 degrees, then how we can write a bar makes 30 degrees, the direction is 30 degrees north of east. So this is north, south, east and west. So if you take the directions are like this is south, this is north, east and south. Here 30 degrees north of east, 30 degrees north of east we can consider, right? Yes. Then or 60 degrees east of north, 60 degrees east of north we can take like this. So like this, once again listen carefully here. This is very important topic, excellent topic, very you can observe in this topic it is very clear the direction of vector 30 degrees north of east and 60 degrees east of north. I'm considering here this is a positive x-axis, this is the first case and this is the second case. They mention very clearly here, right? Now 30 degrees here mentioned, the arrow mark in which direction shows that we have to take first. Observe carefully the arrow mark. So arrow mark shown like this, right, towards north. So that is the reason I'm taking north first, then east. Suppose after mentioning, so if you want to take, so we have to take like this, 60 degrees, remaining angle is 60 degrees because total is 90 degrees. This is 90 degrees. So 60 degrees east of north, east of north. Okay, so that we can consider. And if you want to determine the angle between two vectors, so if you are taking this one vector and another vector like this, it must be the angle between the two vectors must be less than 180 or equal to 180. So this initial point, co-initial point, without disturbing the directions of the vector. So this is A bar and B bar. So these are the two vectors. The angle between the two vectors we can consider less than 180 degrees or equal to 180 degrees also we can consider. So you can represent this 180 degrees. Suppose 120 degrees you can consider. So the linear pair we can consider, that is 180, right? The linear pair is 180. So the angle between the two vectors must be less than 180 or equal to 180 also we can consider. So like this, the angle between these two vectors is 120 we can consider, right? Yes. So that is about the direction of vector. So these are the 3 points, very important. Listen carefully. First point, dear listeners, carefully listen. First point, we have to take vector with the positive x-axis. Second point, if the arrow mark is represented towards the pole or north pole, here north pole I consider. So that you have to take first, then where it is started, that one east, 30 degrees north of east. The remaining angle you have to mention east of north, east of north, like this remaining angle east of north. And third point is compulsory the angle between the two vectors must be are equal to 180 degrees we can consider when without disturbing the directions of the two vectors their initial point will be touching. Clear? Yes. So next one, resolution of a vector. How we have to resolve the vector? Here the definition is clearly given, just check once. The projection of vector in a particular direction is called the component of vector in that direction. Suppose I am taking here this is a vector, I am considering this is a vector A bar. The angle between this with x-axis and vector is theta. If you project like this component is called ax, this component is ax. So we can take the component of a bar in the direction. So if you take OA, like along x-axis OA direction, that is ax equal to a cos theta. How you got this? So you can take this as a right angle triangle, like this you can consider right angle triangle. So anyway, this if you take magnitude and this is the theta, listen carefully, this is very important, most important. Here is x-axis and y-axis. You know, from trigonometry, cos theta equal to, because we are projecting on x-axis, so we have to take adjacent sides. So cos theta, that is the reason we are taking cos theta. Cos theta equal to adjacent side by hypotenuse. What is the adjacent side? X. What is the hypotenuse? A. So x by A. So we can take x equal to A cos theta. That x is nothing but Ax. So here we can take this component of A component of vector A the direction of x-axis. So we can take x equal to A cos theta. So we got like this. Here we see like that we can represent the vector in two-dimensional and three-dimensional also we can consider. Right here I am considering alpha. If it is there in the two-dimensional, we can consider. Now we'll go for two-dimensional presentation of vector. So here you can consider. I'll take here this x-axis and y-axis. So x and y here I'm considering. Now this vector, this A. The angle between A and x is alpha. Angle between A and y is beta. So I'm considering here, right? Now here it is alpha, here it is beta. Then we can consider previously how we did. Like that we can consider. Now we can consider cos alpha equal to ax by a. Adjacent side is x, this is y you can take. So that is x equal to a cos alpha. Then cos beta if you take y by a we can consider, because we can take this is the magnitude of a. So y equal to a cos beta, right? Like that we can consider. Here, understood, right? Yes. So in that way we can represent. Normally we know I cap and j cap are the unit vectors along x-axis. So this x-axis and this y-axis, along x-axis and y-axis. So this x and y-axis along I cap is the unit vector along x-axis, j cap is the unit vector along the y-axis. So we can take a bar equal to xi cap plus yj cap. So we know x and y, so substitute here. A bar equal to, what is x? A cos alpha I cap plus a cos beta j cap. So this is about a bar vector. We got it. Vector lies in the x-axis, y-axis coordinate, right? So we can consider. Here you need to understand alpha plus beta. So what is alpha plus beta? Alpha plus beta, if you take this alpha, this is a beta. The angle between perpendicular lines, that is 90 degrees. So alpha plus beta equal to 90 degrees. We can consider. Now here beta equal to 90 minus alpha you can consider. Beta equal to 90 minus alpha. 90 minus alpha. Now instead of beta you substitute what substitute? 90 minus alpha. So you can consider a bar equal to a cos alpha I cap plus a cos 90 minus alpha j cap. So if it is odd numbers means it will come, cos will become sine, sine will become cos, like that. So a bar equal to a cos alpha I cap plus a sine alpha j cap, a sine alpha j cap, like that we can consider, right? So a bar equal to a cos alpha I cap plus a sin alpha j cap. So this is the two-dimensional representation of a vector. I hope you got clarity about two-dimensional representation of vector. So previously I took right angle triangle, right? So like this we will get cos alpha value and cos beta value also. From that we can take a bar equal to xi cap and yj cap if I cap and j cap are the unit vectors along x-axis and y-axis respectively. A bar equal to xi cap plus yj cap. A bar equal to a cos alpha I cap plus a cos beta j cap. As we got x value and y value, substitute here in this equation, you will get that answer. Here a bar equal to a cos alpha I cap plus a cos. Here you see alpha plus beta equal to 90 degrees. So beta equal to 90 minus alpha. You are substituting beta value here. 90 minus alpha you are getting. So a bar equal to a cos alpha I cap plus a sin alpha j cap. Very good. So this is about resolution of a vector. Then the resolution and two-dimensional representation of vector. So this resolution of vector and direction of vector, two-dimensional representation of vector. Now we will look into that three-dimensional representation of a vector. How we have to represent in three-dimensional way. Okay. Yes. So now we will look into that. I already said I cap and j cap and k cap here z axis, right? So that's why x comma y comma z. So I cap and j cap and k cap. So nothing but I cap is x axis, j cap related to y axis and k cap related to z axis. So I cap and j cap and k cap are unit vectors along the direction of x axis, y axis and z axis. So previously we know how we have to write a bar equal to xi cap plus yj cap plus zk cap. A bar equal to xi cap plus yj cap plus zk cap. So if you are representing so this is a x axis, y axis and z axis. Like this, if you represent, you can take the vector like this is a vector. So a bar I am considering. So x axis, y axis and z axis. I cap is a unit vector, j cap is a unit vector and k cap is a unit vector. Like that we can represent. So with the x axis this alpha, with the y axis beta, with the z axis gamma. So alpha, beta, gamma are the alpha, beta. Here listen carefully, these are very important. Alpha, beta, gamma are the angles A bar makes with the x axis. A bar with x axis, that is alpha. A bar with y axis, that is beta. A bar with z axis, that is gamma. Okay, so here I am considering the angle, right? Gamma we can consider. Gamma. Very nice. Now we know A bar we are representing like this. If you take the magnitude of A bar if you consider, that is equal to a root over x square plus y square plus z square we can take. X square plus y square plus z square, right? Very good. Now we can see first point is cos alpha. Cos alpha equal to, what is the cos alpha from this angle? If you are taking here this x and opposite side is y, so then cos alpha equal to x by, that is a, right? So a means what? Root over x square plus, so here a, So we can take cos alpha equal to x by root over x square plus y square plus z square we can write. Then cos beta we will write cos beta equal to y by root over x square plus y square plus z square. Then cos gamma equal to z by root over x square plus y square plus z square. We can take like this. Clear? These are all called directional cosines. Directional cosines like cos alpha, cos beta, cos gamma. These are all called directional cosines. X, Y, Z are called directional ratios. X, Y, Z are direction ratios. Clear? Now, so previously you know a cap, how we can write a cap equal to a bar by mod a bar. That is nothing but xi cap plus yj cap plus zk cap by root over x square plus y square plus z square. Clear? Like this we can write. If the vector is starting from the origin here and ending from here, so this x1 y1 z1 x1 y1 z1, this is the starting point. Ending point is x2 y2 and z2. How we can write vector a bar equal to, so sometimes we can write a bar equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Like this we will write. So like that way we can represent the vector. So make sure that you're understanding vectors. So here it is I cap. Okay. So a bar equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So like this way we can able to represent the vector in three-dimensional way. Clear? Yes. So this is about representation. Even if you consider two-dimension also the same, but here x square plus y square will come, x square plus y square, x square plus y square. Here until here only we will write if it is in two dimension, if you want to represent in this way. Okay, so that's about three-dimensional representation of vector. Once again you can see first one onwards, direction of a vector, next resolution of a vector, and two-dimensional representation of vector, three-dimensional representation of a vector. Thank you viewers, student the brand. Like, share and subscribe. Like, share and subscribe. Give me motivation to do more videos. If you want to suggest, please suggest in the comment section. Thank you so much.